Okay, today is lesson number 5, tectonic plate motion. I'm just going to review some of the things that you learned from your reading. Make sure that you check your data table for the correct answers and make sure you have those. Um, the challenge question today will be that you can differentiate between the 3 types of plate motion. So by the end of today, you should really understand all 4 of these vocabulary words plus what's actually happening at the 3 different kinds of plate boundaries. So some of this is a review, but I just wanted to go over it since you read about it. So first definition is a transform boundary, and that's when 2 plates slide past each other, causing earthquakes. A divergent boundary is when 2 plates pull apart from each other, causing earthquakes, volcanoes, and volcanic mountains or islands to form. A convergent boundary is when 2 plates collide, and that can cause earthquakes, volcanoes, mountains, and subduction zones, which are new, and we're going to talk about those today. A subduction zone is then defined as when one plate goes under another plate, and those can cause some significant trouble. So go ahead and get those definitions written down, pause the video, and when you're ready, you can move on. Okay, let's talk about transform boundaries. So in a transform boundary, you should have seen that this is where plates will slide past one another like this. In real life, this is what a transform boundary can look like. This is the San Andreas Fault as seen from a helicopter view, and this would be the North American plate, which is moving to the west, and the Pacific plate over here is moving to the north. And so it's rubbing against the North American plate, and that is why California is so subjected to earthquakes. Earthquakes, though, are really the only thing that happens in a transform boundary. You don't have crust being destroyed, you don't have anything being made. It's just the movement of those plates. So, of the 3, although I don't want to be in an earthquake, but of the 3, a transform boundary has the least dramatic effects. Okay. If I am talking about a divergent boundary, 2 plates are pulling apart from each other. And what that does, if you look in this diagram, here's a picture of South America and Africa. And South America and Africa are pulling apart from each other, much like the North American plate and Eurasia are also pulling apart. And what that's doing is it creates this opening in the crust. And in this case, it's in the ocean. And so it creates what we call seafloor spreading, where the ocean floor gets bigger. And the reason why that happens is as the plates pull apart, that magma comes up to the surface and it kind of flows out and down the sides. And it can create volcanic mountains, which can become islands. And it makes the ocean floor bigger. Okay, so the seafloor actually spreads out and you get these ridges, which are essentially mountain ranges underneath the ocean, where these divergent boundaries are creating these mountain ranges. Okay, so those are divergent boundaries. The opposite of those are convergent boundaries. Now, when plates collide, you have 2 different things that could happen. This is when 2 pieces of land collide. And typically when they collide, they push up and they make mountain ranges. That pushing up will make some earthquakes because the ground is rubbing against one another. But they just push up. And this is what we saw when India collided with Eurasia and created the Himalayan mountains, where you just had the 2 pieces of land that rub together, push up, and create these mountain ranges. But sometimes you should have seen yesterday that whenever the ocean plates are involved, there's something different. So if an oceanic crust collides with a continent, or if 2 oceanic plates collide, you get a subduction zone, where one piece, which is more dense, goes underneath the continental crust. So, or underneath the oceanic plate, whichever one it is. When one plate goes underneath, it starts to get heated up in this mantle layer and it melts down. And so because it's adding more liquid rock, and you can think of this kind of like a balloon under here, there's only so much space. The lava or the magma will find the weakest spot and it'll push up. So it's very common near a subduction zone to see volcanoes. Okay, so places like Mount St. Helens, those are caused from subduction zones. We'll talk about that in a second. So volcanoes are actually really common there. And when these sink, it's not a constant sinking. It pushes, 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 and then all of a sudden it pops down and it goes down suddenly. And it causes really big earthquakes. So those can be really dangerous. And if this is happening out in the ocean, if you have a subduction zone, it creates an earthquake out in the ocean, it creates a tsunami. Okay? And what ends up happening with a tsunami is when one plate slips below, the plate that pushes up on the water, and then that pushes the water forward. And the more it gets closer to the shore, you have all of this water that gets pushed into a smaller space, so it gets pushed up higher. And then the closer you get to the shore, the bigger the wave will get. So it doesn't move as fast, but as it gets closer to the shore, but the height can get really, really big. Okay. The tsunamis are very dangerous. Number one, you don't know when the earthquake is going to happen. They're completely unpredictable. And when you have a tsunami, you sometimes only have 15 minutes, depending on how far away it is from the shore, to get out of the way. Okay. I know there was the famous movie, the San Andreas movie with The Rock, and there was a tsunami. That's actually false because the San Andreas fault could never produce a tsunami. So that it was totally Hollywood. But how a tsunami would behave was kind of similar. So we wouldn't see that in California, but where we could see it is up in Washington and the bottom portion of Canada. So there is a plate off the coast of North America called the Juan de Fuca plate. So the Juan de Fuca plate is pushing into the North American plate, and it's creating a subduction zone. And the place where the Juan de Fuca is going underneath North America, they call that the Cascadia Trench. And these are actually called the Cascadia Mountains. You've probably heard that term before. All of these mountains were formed from volcanoes. So Mount St. Helens, for example, erupted, and that was a drastic eruption. I believe it was in 1985 or 83. I'd have to fact check the year. But that was caused by this Juan de Fuca plate melting down and pushing up close to the shore. So the fear is that this Cascadia Trench slips, where the pressure builds and builds and builds, and then you get a big motion, which causes a pretty big earthquake. It happens approximately every 630 years, and they're about due to have one. Now, the concern is there's so much energy there that it could produce a 9.0 earthquake, which is a really, really catastrophic earthquake. And that would create a tsunami with waves over 10 feet tall. And depending on where you lived on this coastline, you would have anywhere from 15 to 75 minutes to get to safety. If you were on the beach, that time would be even less, and it could be very dangerous in terms of getting out of the way. We saw something very similar in Japan in 2011. They had a catastrophic tsunami. At the end of the unit, if we have time, I'll show you a video about the tsunami that happened in Japan, just to give you a feel for what can go on there. Okay, so yeah, I just wanted you to make sure that you understood the different motions. Tomorrow you're going to have an assignment where you're going to kind of do a simulation and play with the plate motions a little bit. But for today, just make sure you have some notes in your notebook. You copied everything down and have everything ready to go for lesson number 5. Okay? Check out some of the videos I linked for you to watch today to add to what I told you here. Okay. Thanks, guys. Have a great day.